Graphing systems of linear equalities. All right, well, we're going to, if you remember, we are going to deal with inequalities such as less than, points to the left, greater than, points to the right, less than or equal to, and greater than or equal to. Those are the symbols that we're going to see in our equations. Inequalities, sorry. What does less than look like? If you recall, it is shown by a dotted line because there is no equal sign there, and we shade below the line. Less than means here's the line, it's below, or we always shade to the left. Greater than, we shade above the line because greater is above. Also a dotted line here because there's no equal sign. And here we do have an equal sign, so therefore the line is solid. Less than, shade below, greater than, shade above. Those you should remember those from when we were working with inequalities. So, example 1. Graph the system of linear inequalities. I have two inequalities. X plus y is less than 3, and x plus 4y greater than or equal to 0. First of all, I would just go ahead and convert inequality number 1 to y equals mx plus b so that I can graph it. And when I do that, I find that the slope is -1 and the y-intercept is 3. And I can come over here and plot the 3 here. -1 of a slope gives me some instructions. Down 1 over 1. So I start here, down 1 over 1, down 1 over 1, and that's how I get this slope here with a dotted line. And so I would just draw the brown line first, and then I'm going to convert the second equation into slope-intercept form. When I do that, I end up with y is greater than or equal to -1/4 x. And notice how I don't have a y-intercept out here. 0 ends up being 0 here. So my slope is -1/4, and my y-intercept is actually at 0. 0, I start here with my first plot, and I also have a negative slope with this one. And so I'm going to start down, and I'm going to go over 4. And that would be my next point. Notice how this line is solid because of my equal sign for the inequality. So it's solid, and so I would have a solid line here, a dotted line here, and then I would have to choose which way am I going to shade this. If you remember, this is less than. Less than is we're shading below the line. So this gets shaded in this area here. Y being greater than -1/4 x is going to be greater than. So I shade everything above the line. And that's why I have this nice little triangle of shade going on there. That would be graphing this particular system of inequalities. Example number 2. Notice I've got more than 2 now. I've got y is less than 2. I have x is greater than -1. And I have y is greater than x minus 2. 3. I got 3 linear equalities. I can graph as many as as many as you want to throw at me. But in this particular case, look what's interesting here. Y less than 2, well, that's nothing other than the y-intercept. X greater than or equal to -1, that's an x-intercept. And then, of course, this one here takes a little more doing, but it is already in y equals mx plus b form, or minus b in this case. So they are actually, we don't have to do any, we don't have to put it in slope-intercept form to graph this out. So let's just go ahead and do the graphing. Take y less than 2, same as y is equal to 2. So we go right here at 2, 1, 2 from the origin, make a dot right there, and then you remember that a y-intercept gives us a horizontal line here. And you can see that there's no equal sign, meaning, so I have a dotted line here, which means it really does not include 2, but this is where we have to make our graph. It says less than, so I'll just leave that right there. I go to the next one, y greater than or equal to -1. I find -1 on the x-axis, and I have a vertical line, which is undefined. Notice how this line is solid. Solid because I have an equal sign, and it actually does include, as a solution, -1. Then the last one here, we can see here that -2, that's the y-intercept for y equals mx plus b. I come down here to 2 for the brown dot, make a dot there. My slope is 1 over 1, or up 1 over 1, up 1 over 1, up 1 over 1. And so I get a slope that looks this type of incline right here. And notice that this line is dotted. No equal sign, that's dotted, it's not solid. Now I do my shading. When I look at my shading for here, this says that y is everything less than 2. That means it's got to be below the line. So I have a little bit of purple going on in here. And I'm only going this far because I know this section here is the only thing that they're interested in me shading, because this is the whole system together is just going to be, all the solutions of this are all in here. Every point in here will work for all of these. What am I going to shade for the x is greater than or equal to -1? Everything to the right. Remember, greater than on the number line, to the right, the higher, the more positive, we get higher, greater numbers. And then, of course, this one here is also greater. So this is above the line. 3 equations, all lined out, all mapped out together, using the appropriate inequality to tell us where to shade. And we have a solution set of in here pictorially. All right, last example here, something a little different, and we're going to go backwards. This time I'm going to give you the graph, and I want you to write a system of linear inequalities from looking at the graph. Let's look at the first one here first. I'm going to call this purple line equation number 1. If I look at it, it's bounded by the line that passes through points 0, 1, 0, 1 right there, and the point 3, 4. 1, 2, 3, 1, 2, 3, 4 right there. And so these 2 points, the line passes through there. And if you remember, we can use the slope formula to at least find out what the slope is. And this also, being on the y-axis, gives us our y-intercept. And we can use slope-intercept form to write the equation for this line right here. And it's going to be inequality. So we take the slope, 4 minus 1, 3 minus 0 from here, and we find out the slope is 1. So up 1 over 1, up 1 over 1. Nice, even pattern. We use the slope-intercept form to find the rest. So you know y equals mx plus b, so I'm going to do y equals, the slope of 1 goes right in front of the x, and we don't need it there. It's implied because x is there. And then plus 1. Where did this come from? Right there. The dot right there on the y-axis at positive 1, that's where this comes from. So in order to write the inequality from this form here, we're just going to insert what we see as far as the shading goes and what the line is to figure out what symbol falls into, instead of equal sign, it's going to be less than or equal to. Notice the shading is below the purple line. The line is solid, meaning the line has to be equal to, and y has to be everything below it. So that is where the less than or equal to x plus 1 comes from. The second equation, or inequality right here, I'm looking at x is 3. X-intercept right there. And I can use the x-intercept to help me write the other equation. The x-intercept and the equation would just be written x equals 3. Well, they are telling me that this is a dotted line and everything got shaded to the left. Left, less than. So we're going to just take and convert the equal sign to the new symbol here. X is less than 3. How do I know it doesn't have an equal sign? It's because it's a dotted line, which means it does not really include 3. However, we have to show it up to 3. X less than 3 is inequality number 2. And y less than or equal to x plus 1 is inequality number 1. So these two inequalities, we went backwards, basically looking at this, and now we can go either way.